Good afternoon, everyone. In this lecture series, we are going to see about the S matrix representation of waveguide, corners, bend, and twist. So, in the previous video, we have talked about the S parameters and what are all the properties of the S parameters. So, in this, we are going to see about the waveguide discontinuities. So, suppose if the direction changes, what are all the things happening? There would be a mismatch and there will be a losses. It is due to that of the radar and satellite layouts, and there will be compact microwave circuits. There will be signal integrity. So these are all the things that has been used in the waveguide discontinuities. So the direction changes. Suppose if we are taking the directional, how it has been used in the waveguide. So the three main parameters we are going for this is, one is corner, the next one is bend, another one will be twist. There will be abrupt change in direction. So that is termed to be as the corner. So there will be significant reflections. That is termed to be as the corner. The next one we are going to see the bend. Suppose if there is directional change, it will reduces the reflections. The third one is twist. So why we are going for this twist is rotation of the axis, and it is also useful for the polarization control. These are all the three things it is needed for this S matrix representation. As in the previous video, I have mentioned that why S parameters has been used means that is low frequency. There will be some disadvantages in the low frequency, and we are going for the high frequency in S parameters is nothing but the high frequency parameters. So what are all the parameters? It depends upon the incident wave, reflected wave, and multiport modeling. So these are all the need that is required for the S parameters. Suppose if it relates to the waveguides or the bends or twist, so what is the thing it has been, what is the reflection and the transmission that is used here means there will be small power reflection and there will be high power transmission. The next thing, while coming to that of the corners and twist, let us see how the geometric discontinuity it will be used in the waveguide. Suppose if it is a corner, the higher reflection and the possible mode conversion has been used in the corner. If it is twist means there will be minimum reflection and polarization rotation. So this is the difference between the corners and the twist. Suppose if we want to minimize the signal loss and reflection in the waveguide, so what we will use means we are going for two types of cases. One is ideal case, another one will be the practical case. Suppose in case of the ideal case, there will be no reflection and the transmissions will be perfect. But in case of the practical case, there will be some loss and there will be finite reflection. This is the difference between the ideal case and the practical case. The next thing we are going to measure and validate what are all the losses we are having. For example, we are having return loss, insertion loss, vector network analyzer, and the measurement. Suppose if we had taken the return loss, we are concentrating only on the reflection, that is signal reflection at waveguide continuities. Suppose if we are going for the insertion loss, we are going to assess the signal attenuation through the waveguide components. VNA, it is used for measuring the waveguide, and for reflection and transmission coefficients, we are measuring S11 and S21. So these are all the applications we are using. We are using in the antennas, radar, and satellite. So in order to obtain the efficient waveguide performance. So this is the mind map. We know that why we are going for this S parameters and what are all the components that has been used how the properties of S matrix is related, and what are all the measurements we are taking, and what are all the applications that has been involved in this. As I have mentioned that there are so many disadvantages in the low frequency parameters, and that is what we are going for the high frequency parameters. So here when these components are related to the S matrix, we know that for waveguide corners, bends and twists, that has been classified for the waveguide discontinuities, and the main reason for using the parameters is based on the power based analysis, and it is suitable for the microwave frequency. And the bend primarily causes the small reflection and transmission loss. So these are all the assessment questions. Thank you.